Hello everyone and welcome back to our videos. Today we will talk about the last force that affects the aircraft and its drag. Also we will talk about the aircraft axes. A drag is caused by any aircraft surface that deflects or interfaces with the smooth airflow around the airplane. A highly cambered large surface area creates more drag than a small moderately cambered wing. If you increase airspeed or angle of attack, you increase drag and lift. A drag acts in opposition to the direction of lift, opposes the forward acting force of thrust, and limits the forward speed of the airplane. A drag is broadly classified as either parasite or induced. What's the difference between parasite drag or induced drag? We will start with the parasite drag. Parasite drag includes all drag created by the airplane. Also, parasite drag normally is divided into three types. A form drag and is created by any structure which protrudes into the relative wind. The second form, the skin friction drag, is caused by the roughness of the airplane's surface. And the last form of the parasite drag is the interference drag, and it occurs when varied currents of air over an airplane meet and interact. For example, the mixing of air where the wing and the fuselage join. The second type of drag, the induced drag. Induced drag is the main byproduct of production of lift. It's directly related to the angle of attack of the wing. The greater angle, the greater the induced drag. Since the wing usually is at a low angle of attack at high speed and a high angle of attack at low speed, the relationship of induced drag to speed also can be plotted. Total drag. The total drag is not a type of drag, but it's a calculation of both the induced drag and the parasite drag. The total drag for an airplane is the sum of parasite and induced drag. The total drag curve represents these combined forces and is plotted against airspeed. Now we will talk about three axes of flight. All maneuvering flight takes place around one or more of three axes of rotation. They are called longitudinal axis, lateral axis, and the last one vertical axis. The common reference point for the three axes is the aircraft's center of gravity. Here we have the longitudinal axis, and here we have the lateral axis, and the last one the vertical axis, and all of them centered by the center of gravity. Here we have the axis and the movement around the axis and the control surface from the cockpit, or no, the control surface who will make the movement. We will start with the longitudinal axis, and the longitudinal axis make a rolling, and as we see here we have the longitudinal axis and the movement it will be around the longitudinal axis. It's called roll. Who will make rolling for the airplane? The aileron who will make the roll movement. And as we studied before, when the aileron will move, one it will goes down and the other it will goes up for make the rolling. So the rolling it will be around the longitudinal axis and the aileron who will make the rolling. After that we have the lateral axis. We have a pitching movement around the lateral axis, as we see in this figure. This the lateral axis, and the movement around the lateral axis is the pitch up and pitch down. Who responsible for make pitch up and pitch down? Of course the elevator, and the elevator it's on the horizontal stabilizer, and when the elevator goes down the aircraft it will goes pitch up, and when the both elevators go up the aircraft it will make pitch down. The last axis we have the vertical axis. The movement around the vertical axis called yawing. This the yawing of the aircraft, and it will be around the vertical axis. Which control surface will make this movement? Of course the radar, and the radar is located on the vertical stabilizer. For more emphasis, we will illustrate each movement around each axis and which control surface will make this movement. And I will start to illustrate the aileron and which movement will make the rolling around which axis, the longitudinal axis. As we see in this figure, this the longitudinal axis, and here we have our ailerons. The aircraft want to make rolling for the left. So when the aircraft will go to make rolling to the left, the right aileron will goes down and the left aileron will goes up. Here when the right aileron goes for down position, the angle of attack will increase and will rise the right wing. The opposite things will happen with the left wing. The aileron will goes up, the angle of attack will decrease, the left wing will goes down. That will make a rolling around the longitudinal axis, and it will be for the left side. The second movement is the pitch. So who will make pitch up and pitch down? Of course, the elevator control surface around the lateral axis. The aircraft wants to make pitch down, so the elevator will go down. When the elevator go down, the angle of attack will decrease, and when the elevator decrease the angle of attack, the tail of the aircraft will rise. When the tail will rise, of course the nose will go down, and this called pitch down. And this movement, it will be around the lateral axis. When the aircraft wants to make pitch up or rise, the elevator will go up. When the elevator go up, the angle of attack will increase, and the tail of the aircraft will goes down, and the nose will rise up. That will make the pitch up movement. And of course, this movement, it will be around the lateral axis. The last movement we have the yawing. Which control surface will make yawing for the aircraft? Of course, it's the radar, and it will be around the vertical axis. As we see here, this our radar. The aircraft will make yaw for the left, so the radar, it will move for the left. When the radar will goes for the left, the aircraft or the nose of the aircraft will turn for the left and will make turning to the left side. And this movement to the left, it will be around the vertical axis.